Okay, we are back. So last time I finished talking about the asynchronous way of programming a web crawler versus the synchronous way, which is up here. So now what I want to talk about is this section. It's called programming with callbacks. So as I hinted to in the last section, it may be kind of convoluted to use this callback mechanism. So the nice thing about the callbacks is that you have only one thread, right? So in this whole example, there is only one thread of execution that just runs. And it just so happens that you are relying on the select call to stop and to give you callback functions to run whenever it wants. So you don't have to deal with any of the problems of multi-threading, race conditions, debugging, concurrency issues and so forth. But instead, the curse that you have now is what's called callback hell, or really convoluted control flow. So here is an example. To write a full web crawler, what they do is they have these two sets, right? They have a to-do set and a scene URL set, both populated with /, which is the home page, I guess the root directory of the URL of the web page. So what they do is that they create a fetcher, which is a class, and in the constructor of that class, it will have some response binary blob, which represents essentially the string that you're going to download from the web page. There's a URL, which you pass in as a constructor, and then there's a socket. So this is a fetcher class, and then a method on the class is called fetch. So what does this do? So whenever you create a fetcher class, an instance of fetcher, an object with a URL you pass in, then what you do is when you call something .fetch, it will, as soon as you call fetch, it'll create a new socket, make it non-blocking. So we're going to use asynchronous IO. Then it's going to do the connection thing. It's going to connect XKCD. It's going to connect, and again, this whole thing will just pass over. Then it's going to register the global selector. So recall the selector is a global variable. It's going to register it with this socket's ID with write, and then self.connected. So self.connected is a method that that is associated with this fetcher instance. So what is, I guess they don't show self.connected, but anyways, imagine this is just a callback function that runs. Okay, so what happens here? So let's say that we create a fetcher, and we're going to pass it this URL /353. So we want to fetch the xkcd.com homepage, and then 353, which is the name of the URL itself. So so we're going to create a fetcher object. We're going to call .fetch. So what this does now is that this creates a new socket, sets it to non-blocking, it tries to connect XKCD, and then registers the selector to call its own connected method whenever it's done. So when it does this, after it registers, the while true loop goes. So this is the same kind of blocking true loop, a while loop that we saw in this example here, right? It's a similar loop where we do selector.select in the while true. So in here, we have the same pattern. And then what happens is we're going to call, we're just going to call this callback. And now we're going to actually pass some parameters in the callback. We're actually going to pass the data associated with the selector event into the callback function, so we can actually use it. So here's a connected method. So we talked a bit about where it connected with. So recall that there's a fetcher class, and then there's init, there's fetch, and then here's connected right here. Okay, so as soon as the connection is ready, so where does the control flow go? It goes here. It goes really fast. It says register my connected, and then it goes here. And then whenever I'm done connecting to xkcd.com, which is a second later, I will run this callback, calling it with event key and event mask. So what is the callback? It's self.connected. So again, we're starting to see some convoluted code here, right? We have a method here that registers some other method and then jumps down to some outside code. And then this code calls a callback, which now jumps into here, which jumps into here, into connected. And now what does this connected do? The first order of business, besides printing connected, is to unregister the file descriptor, the ID essentially, of the actual socket that I just connected. So this unregisters myself. I suppose we could have used self.socket too, I guess, instead of this. But anyways, it unregisters so we don't get a duplicate event. Then it tries to make a request, this request string, and then it does self.sock.send that request. So this will send the xkcd, whatever, the URL request to xkcd. So again, this thing is non-blocking. So this does not wait until the data is sent before it keeps going. It just keeps flying through because it's non-blocking. So in order to do something sensible when this thing is done, we need to again call the global selector to register another selector event, which is now called event read. So event read is fired. This event is fired when basically this request to send stuff to the server is done, and we're now ready to read a response back from the server. So the sent, I guess you can say, writes data on the socket to the server, and then we're going to wait until the server, we're ready to read data back from the server. And when we're ready, we're going to make another call to another callback called self.readResponse. And so what happens after connected is done? What happens is the control flow is going to fly back to this while true loop, right? So this callback is connected. We're going to fly back to while true, but now my selector has been registered for this event read event. So the next time select gets called is when this request gets done and we're ready to read from that socket. And then once that's done, we're going to go here, we're going to grab the callback and we're going to call it. So what's the callback the second time we go through here? It's not this anymore, right? Because we unregistered that. It's this self.readResponse because we registered a callback called self.readResponse now. So now we're going to actually jump down here. Whoops. We're going to jump down here to read response, which is again called after this whole shindig gets done. After this whole thing gets done, and then we're gonna jump down here and we're gonna do this receive thing going on. Socket.receive, and then we're gonna keep reading. We're gonna read a chunk in, and if we are done reading chunks in, what we do is we unregister the handler to say we're done reading. We're going to parse the links, which again is not defined yet. We're going to find if we need any new links, and then we're going to create a new fetcher object in here, and then we're going to do some bookkeeping. And then if we're done, we can say stopped and we're all done. This is a global variable. So the key here is that the first time let's say our web page is above 4K, right? It's 100K or something. The first time we run this read response, we're just going to go boom, receive it. This goes, pretty fast, and then we're going to go up here. And then we're done because we're totally done with this function. We're clear. We don't do the else. We just do the if. So now what happens is our read response callback is still registered in the selector up here. So then when I have more data to read, when the server sends me the next chunk, I'm going to go back through this loop and call this again. And I'm going to keep on calling read response until chunk is empty, until there's no more to read. And then I unregistered myself because I don't want to keep calling read response once I'm done reading. And once I unregister myself, I parse my whole web page. So now I think self.response has everything. It has my whole web page. I can parse all the links. I can now go follow all the links. So there's some logic to make sure I'm not following duplicate links. And the key here is I actually create a new fetcher initialized to the link that I am trying to go to, and then I create a new fetcher and then I do .fetch on this. So the key here is that I am now not only, let's say I had 100 links on my webpage, right? So let's say I had 300 links on this webpage. This will literally go through all 300 links and call create a fetcher object for each one and call fetch on it. So this will literally go through all the links, because again, this is just a iterator. It will create a fetcher object for each link and then call .fetch on it. So this in effect goes through and creates, say, for this extreme example. This creates 300 fetcher objects all instantaneously pretty much, and puts it in a, and calls fetch on all of them. So in this case, after we're done with this, this will call fetch. So this will go all the way up here. Each one of them creates, let's say I had the 300 example, right? Whoa, I did all 300. Each one of them will now create its own non-blocking socket. So we have 300 sockets. Register tries to access XKCD and then registers it with the selector, and then it will go through the loop, and whenever one by one they get ready, it's going to call connected on each of them. It's going to send a request for the URL. Remember, each of the 300 has a different URL now, right? It's one of these different URLs, and then it will, when it's ready, it'll go to the read, and it'll go here and it'll read and stuff. So if this explanation sounds really confusing, it's because it is. The whole point is that this control flow is really convoluted. It's jumping between different methods in this selector loop, and then different methods. We're registering callbacks, we're unregistering callbacks. This is kind of a spaghetti mess of code. And this example here is just, this is the same as the above example, except we have a stopped global variable because we want to stop the iteration when we're, say, done. When we're done fetching all the pages on a website, we want to say stop. But it's essentially the same deal, the selector here. So this says basically async problem is really tricky is because it's spaghetti code, right? That the control flow is super hard to understand because you have to jump between all these different things because some things are synchronous, some things are asynchronous. And this makes debugging really hard, even though the whole point of having a single threaded app that's non-blocking is that you only have one thread to worry about. But you do only have one thread to worry about, but it's the control flow just keeps jumping everywhere. So again, this is the example of the blocking version or the single threaded version, which is much simpler to understand, right? We're just creating a socket. This again waits until it's done creating, do connect, wait until it's done politely, send, wait until it's done, receive, wait until it's done, wait until it's done. We're all done, parse links, go to the next one, add to the queue, and there's probably some loop that drives it. This is nice and polite, but the problem again is it's super slow if there's only one thread. And if you have multiple threads, you have a multi-threading problem. So we're faced with this dilemma between really clean code that's inefficient or prone to many threads, which is also inefficient, or really efficient code that's single-threaded and uses asynchronous I/O, but it's just crazy and all over the place. So the promise of this article is to show you a way using what's called coroutines to basically get the benefits of the clean code that you get in the blocking or single-threaded version with the also the benefits and efficiency of the single-threaded async I/O version. So the idea is that we want to write code that almost looks like this, but that performs really well like this really convoluted weird code with all the select and stuff.